My dear students, till previous lecture we have completed the exercise 6.5 and I am going to take up the questions of 6.6. 6.6 is optional. I have realized that some difficult problems are there in this exercise, so I thought I will attempt all the questions of this exercise. So I have started this question number 1. In figure, PS is the bisector of angle QPR, right? Prove that QS upon SR is equal to PQ upon PR. It's a very good problem, so we will take up. So for this, what we will do, I will draw a line segment from S parallel to PQ. One construction I will be doing. So I will draw a line. Suppose it is ST. So construction, draw ST parallel to PQ. I have drawn ST parallel to PQ. So now we will talk about two triangles, PQR and TSR. So we will see what kind of relation we are getting in the angles of these triangles. Now PQ is parallel to ST and this is the transversal, then the corresponding angle this, suppose it is X, will be equal to this, right? So if it is in degrees, we will write X degree, measure of the angle. And correspondingly, these two are parallel I have drawn, and QR is the transversal, the corresponding angle this will be equal to this angle. Suppose it is Y degree. And this angle, suppose it is P degree, it is common in both the triangles. Now, in triangle PQR and triangle PQR and triangle TSR. So, angle PQR is equal to angle TSR, and angle QPR is equal to angle STR, right? Corresponding angles. So these angles are equal due to correspondence. These are the corresponding angles. That is why these two angles are equal. Therefore, triangle PQR is similar to triangle TSR by AA criterion. This we have already studied. If you want to see rest of the lectures, you can go in my playlist. You will get all the lectures on this particular chapter. So, due to AA criterion, these two triangles are similar. Since triangles are similar, the ratio of the corresponding sides will also be equal. So we look at the correspondence. PQ corresponds to TS. Therefore, PQ upon TS is equal to PR upon TR. PQ upon TS and PR upon TR. This relation we got. Simultaneously, we will get these two triangles are similar. This is parallel. Therefore, PS QS upon SR and QS upon SR is equal to PT upon TR. PT upon TR. These two relations are there, 1 and 2. From these two we will proceed. What is required? QS upon SR is equal to PQ upon PR. From first. Therefore, from equation 1, PQ upon PR, we will go by cross multiplication. So we will get PQ upon PR, that is equal to TS upon TR. TS upon TR. And here QS upon SR, right? It is equation number 3. What is given? PQ upon PR and QS upon SR from third and second. So right hand side must be equal. Then only left hand side will be equal. So we will talk about this particular triangle we will look at. Now this is parallel to this and this is the transversal. See, these two PQ and TS are the parallel lines and PS is the transversal. Then alternate angle will be equal, means this angle will be equal to this angle, right? Since PQ is parallel to TS, therefore, and PS is transversal, therefore angle QPS is equal to angle TSP. These two angles are equal, and we know if PQS is equal to TPS, but angle QPS is equal to angle TPS as PS is angle bisector of angle QPR. Since PS is the angle bisector of this angle, so these two angles will be equal, that I have mentioned over here. Therefore angle TSP is equal to angle TPS. These two angles will be equal. This angle and this angle. This is equal to this. Therefore, side opposite to these means TP is equal to TS. Therefore, TP is equal to TS. Sides opposite to equal angles of triangle TPS. So TP is equal to TS. Then from equation 2 and 3. See, equation 2 is QS upon SR is equal to PT upon TR, right? And PT is equal to TS upon TR. Since PT is equal to TS. From this, I let this equation number 4. Therefore, from 3 and 4. Here RHS is equal, therefore LHS will also be equal. Therefore, QS upon SR, that is equal to PQ upon PR. This was required to be proved. See, that is proved. So we will take up the question number 2. In figure, D is the point on hypotenuse AC of triangle ABC. ABC is also right angle triangle, and DM is perpendicular on this. This is perpendicular on this, and DN is perpendicular on AB. So we have to prove these relations. Solution. See, first we have to prove this. DM square is equal to DN into MC. So DM is there, MC is there, and DN is there. So DN is equal to MB because it is 90 degree. This is the rectangle, so opposite sides will be equal in this case. So we will consider these two triangles and we will see the angle, corresponding angles. Which are those angles? Here we have already studied. When I was teaching similarity, I had told you one thing. Suppose if this angle is x degree, then this will also be x degree, and this is y degree, then this will also be y degree. This I have already done and it is very easy to understand. See, BDC is the right angle, and x plus y is 90 degree. I hear x plus this angle plus 90 degree means this plus this is 90 degree. Since it is y, this will also be y. Correspondingly, since it is x, this will also be x. So we will consider these two triangles. So we will write how these angles are x and y, that I will make you to understand. So from triangle CDB, angle DCB plus angle DBC, that is equal to 90 degree. What is DCB? DCB is x degree, that is x degree plus y degree is equal to 90 degree. This is the first equation. And if you are taking triangle DCM, in triangle DCM, so here angle DCM plus angle CDM is equal to 90 degree because this angle is 90 degree, and DCM is x, therefore x degree plus angle CDM is equal to 90 degree, therefore angle CDM is equal to 90 degree minus x degree. So this is equation number 2. From 1 and 2, therefore angle CDM is equal to y degree because 90 degree minus x is y degree. So this we have got. So this angle is y, and on homework I am giving you, just find this angle, you will find it is equal to x degree. So in these two triangles we will look at, right? In triangle DCM, and you see DCM we have taken. This is y degree, this is x degree, this is 90 degree. So we will write for this triangle with the corresponding angles. So first this vertex I will write because it is angle y. D is y, so we will write B first. So B and x, that is D and M. In these two triangles we will look at. Angle DCM is equal to angle BDM, and angle CDM is equal to angle DBM. CDM is equal to DBM. Angle DBM. Right? Corresponding angles. Therefore, triangle DCM is similar to triangle BDM by a similarity. Criterion of similarity. By A criterion of similarity, these two triangles are similar. Then we will go for the ratio of the corresponding sides. Therefore, corresponding, because we want dm square. So dm corresponds to bm over here. Dm upon bm is equal to, we want mc. So cm corresponds to dm, right? So we will write cm corresponds to dm, because cm, these two letters, and the last two letters. So by cross multiplication, therefore dm square is equal to bm into cm. We got this relation. dm square is equal to bm into cm. So cm is there, bm. So here bm is equal to nd, right? Therefore dm square is equal to dn into mc. Since dn is equal to bm, as d and bm is a rectangle. This way we have proved this relation. That is proved. Because D and BM is a rectangle, because all the four angles are 90 degrees, then opposite sides will be equal. Therefore DM is equal to BM. So that I have proved. First part is proved. Now we will go for the second part now. DN is parallel to CB and AC is transversal. Therefore, angle ADN is equal to angle DCM is equal to x degree. That is corresponding angles. And DM is parallel to AB and AC is, therefore angle DAN is equal to angle CDM is equal to y degree. Again it is corresponding angles. Now in triangle DBM and triangle D, this vertex of this triangle corresponds to same x, it is here, so it corresponds to D only. So D, B means y, here it is A, so D A N. Angle DBM, angle DBM, that is y, it is DAN, angle DAN. And for x, MDB, angle MDB is equal to angle NDA. This is equal to DBM, it is y degree, and that is equal to x degree. Therefore, triangle DBM is similar to triangle DAN by a criterion of similarity. If these two triangles are similar, The ratio of the corresponding side we will write. Those will also be equal. Now we want dn square. So d and n corresponds to dm. Therefore dm upon dn, dm of this triangle and dn from this triangle is equal to an. We want an also. So bm upon an. This relation we will be getting. Therefore, we will write by cross multiplication dm into an and mb into dn. So we will write bm into dn is equal to dm into an. bm into dn. You see in this rectangle d and bm. So bm is equal to dn. Right? Therefore dn into dn is equal to dm into an. Since d and bm is a rectangle, therefore dn square is equal to dm into an. This is proved. So children, we have solved 2 questions. The remaining questions we will be attempting, and we will make another video with those questions. And if you want the whole triangle, number of lectures were there, so all those lectures you will get in the playlist.